The next speaker is Mr. Leopold, Regional President of Asia Pacific of Bosch Sensortec. And his speaking title today is Sensors as Enabler of the Internet of Things and Service. Let's welcome Mr. Beard.
Ladies and gentlemen, thank you for the invitation. Oops, this is moving. Not too far, fortunately. So thank you for the invitation, and well, kind of unpleasant to present after the big picture, to go in the much smaller microscopic picture, but I try my best on that part, and I also try to provide a link how these microscopic structures, MEMS we are talking about, influence the macroscopic big business that we were been talking about before. So looking at my presentation, first slide, of course, I tell you something about Bosch, the company I represent. But looking at my presentation, I'm shortly go back into not so far history to explain the basis of MEMS, and then slightly approach towards giving a prediction on the future based on today's situation related to MEMS and related to the semiconductor industry that impacts MEMS. So shortly about Bosch and MEMS. Before telling you what MEMS is anyhow, Bosch is the biggest supplier of MEMS sensors globally. Bosch been traditionally in this business by inventing the deep reactive ion etching process that is on the basis of every MEMS manufacturing today. So even our very nice and fierce competitors today, they use a Bosch process when they compete with us. And business started in the automotive, as you can imagine by the name of Bosch, but moved very quickly into consumer electronics and spreading now into industrial and industrial business and into what we call today Internet of Things environment or ecosystem. So already with this slide, you see how we predict the future. History has been automotive, although by far not dead today. I'll talk about that. Today, big business is in consumer electronics, but tomorrow's big business will be in application and use cases that today we just think they will be there, but we are convinced they will appear, even though we don't know how these use cases will look like exactly today. So what is MEMS? MEMS stands for Microelectromechanical Systems, and I'm really talking about mechanics. I know most of you, or lots of you, are semiconductor people, and when you talk about microns, you talk today about nanometers. At my time at universities were still micrometers. I'm back to the micrometers from semiconductors, and we're talking on really about mechanical system. The beauty of it is every MEMS is a system. Every MEMS device you see is a system system in a package. Means we have a micromechanics element and we have silicon inside. So that's why today there's a big hype behind MEMS, and I might even assume lots of the people hyping MEMS rather are greedy about the silicon inside than the mechanical part inside, but nevertheless, both of them belong together and you cannot separate this functionality. Of course, at the basis of everything is the deep reactive ion etching process, which allows diffuse aspect ratios so you can mechanically structure silicon. Silicon. I think I don't need to explain to you what silicon is. It's this famous element in the fourth elementary group. We are carbon people, you know. We humans, we are based on carbon, same fourth chemical element group. Silicon is the next element, and silicon enables our electronic world. So the silicon world is complementary to our carbon world, us as humans. But what we tend to forget is that silicon, beside these semiconductor properties that enable the big industry, also has exceptional mechanical properties. Silicon mechanical properties are much better than steel. One, tensile strength, if I remember well, is 3 times that of steel. And secondly, silicon is does not wear off. That means if you have a silicon spring, until you break this spring, it will behave linearly, which Few elements in the macroscopic world behave like this. Silicon fortunately is. And of course, as you all know, silicon also allows us to integrate electronics with mechanics. This is the conventional part. So silicon is very special. And by this, I gave already one part of the explanation. Why is MEMS so successful today? MEMS is successful because MEMS is based on a very special material, but uses this material in a way where it can be very cost effective by using semiconductor processing. As you all know, batch processing, highly standardized, allows huge economies of scales and allows cost reduction potential. Size and weight, not discussing, for mechanics, microns is very small. Power consumption, if you use small masses, if you use small amplitudes in mechanics, you move lesser electrons, lower power consumption, very simple. And in addition, you can integrate mechanics with electronics, means having a total system on one silicon die. So this, in fact, is the reason for the success of MEMS, and this is, in fact, also the reason for why today we talk a lot about MEMS, and this is why we project a big future for MEMS. So, as promised, looking back in history, MEMS big business, or at least big scale business, was started in automotive in 1904. I think the first MEMS product was a lambda sound. Then there were crash sensors, whatever, gyroscopes for electronic stability. However, the market was growing stably in the range 5 to 10% per year. Then in 2006, we had a disruption in the market. We had the Nintendo V coming up. We had later a first iPhone coming up. These were consumer electronics devices that used a MEMS device for the first time on a bigger scale. And this started an avalanche of use cases. Today, every smartphone, at least a higher-end smartphone, has at least 3 MEMS sensors. Today, gaming devices without motion interaction, you cannot really imagine them. And HMI devices like this usually also have MEMS sensors. So you've seen the business scaled up to the numbers of consumer electronics devices. The question is, what's next? And how does the industry look like? And I agree, we have economical uncertainties, but we also have technical uncertainties, how the next step would be for Internet of Things integration. For this reason, the answer of Bosch was, as we traditionally focus on technology, go back to our strengths, prepare the basis of technology for applications that today we might not fully know. So if you look at this, lesser from a Bosch perspective, but look at this chart. Usually when you see hockey sticks, this is when your marketing people try to sell you the future. But this chart, in fact, this is a reality. And this chart indicates something. This chart indicates something, that something happened in MEMS, and this something happened in 2008, 9, 10. I told you before what happened, the adoption of MEMS in consumer electronic devices. But this chart also shows that we're transitioning from high volume. In 2010, Bosch produced more consumer electronic MEMS than automotive MEMS. So we've been in a transition phase from one industry to another. Today, consumer electronic drives MEMS technology. And the question is, when will be the transition towards the next industry? Our guess is probably later than analysts say. It's probably in the range of 2020, but it will happen. So question, and also part of my presentation today is, how will these systems look like? And what do we need to do to survive in this new economy? First, you ask, okay, nice hockey stick. How did you do the hockey stick? Very simple and very complicated. It's not like semiconductor business is achieving hockey sticks, and this is the first big difference to traditional semiconductor companies. We have a multitude of technologies that we need to serve. This might look like a minor technical detail, but in the end, this leads towards the players in this market being totally different players than typical semiconductor companies are. You need to cover inertial kind of sensors, not going to detail, different types. You need to cover geomagnetic technologies, gas sensing, environmental stuff. You need to integrate them with microcontroller, again, traditional semiconductors, and you need to add acoustic property chips to it. So you see you're active in lots of domains with lots of technologies. That means we need to scale our company towards being effective in lots of technologies and being able to merge these technologies. So today's industry trends, which in fact will point us towards tomorrow's reality. If you look back again, 2019, as mentioned before, first big wave was automotive. Second wave, consumer electronics, still growing, but with stabilizing growth rates. So we had years of 20 to 25% per year. We even had a year of 40% turnover growth last year. But this will slow down in consumer electronics. That means we will see a stabilization of the growth in MEMS for consumer electronics. Analysts expect in the range of 10 to 12% per year. I think this is realistic. But this also means the big times of growth in consumer electronic MEMS are over. So what's next? As you know, growth drives profitability. So we're all looking to grow our business, and we tend to position our companies to generate growth. So the next wave, we call it the third wave of MEMS growth, is related to the Internet of Things and services. But let's look at these three evolution parts. Now the question you might ask is, okay, is automotive dead? Definitively no. We will see all these three new branches evolving. We will see new applications arising in automotive and new solutions for today's challenges in automotive. We will see consumer electronics continuously introducing new use cases for MEMS sensors, and we see higher penetration rates. In fact, the prediction is that every battery device comes with at least one MEMS sensor. Now you imagine how many batteries are produced every day. Yeah, so that should be the target market, at least for every battery, at least one MEMS sensor. So you see we still have room to grow the business. And the evolving markets will run in parallel, but the assumption is, and I will present some facts on which these assumptions are based on, the assumption is that these new markets will require different solutions and new solutions. So when we saw the transition from automotive to consumer, it was not as easy as we initially thought. We take a nice, proven automotive technology, we give it to the smartphone guys, they will be happy, they buy the same thing, and we'll have the economies of scale. It was by no means that way. It would have been nice. I would have loved it, but it wasn't. So reality again struck. Reality was different than we wanted it to be. So therefore, I would not do the same mistake again and expect that the new markets are just an evolutionary step of today's consumer electronic markets, because usually life is not that way. Look at cars. Today, you have something like 50 MEMS sensors in a not so highly spec'd car. So there are cars with significantly more MEMS sensors in it. You may say nice, but you're in trouble. I would just smile, because when we talk about the change in powertrain from combustion engine to electrical cars, of course this will cost some sensor on one hand, but these firstly are not so many. On the other hand, it will introduce further sensors related to autonomous driving. So whenever you think automotive sensor market is dead, wrong. I think, and we're convinced, it still has a very nice life ahead. As long as we have individual transportation, sensors for cars will grow. And as you see, the major chunk of the business today is related to comfort and safety. Add autonomous driving to it, you will see that the value of the sensors generally will triple. That's the assumption of the analysts. Consumer trend. So we talked about automotive. Automotive is okay. Growing at a rate of 5% is the general analyst assumption. What's happening in consumer? The consumer growth is hugely impacted by the massive shrink rates we have and the huge price decrease rates. So we have first consumer devices which are accelerometers, where we see today decreasing markets. even though increasing shipment numbers. This is a trend that will stay with us definitively, because this shows that some of these application fields are mature. What it means for us that on one hand, we still need to drive innovation because our customers want smaller, better, cheaper. But on the other hand, we also need to develop new solutions, new technologies to fuel the growth and to finance our R&D. So definitively one trend is make it smaller, and it's impressive when you think this is mechanical scaling. This is not just the CMOS scaling. I say just, of course, because for you semiconductor guys, you used to talk in nanometers, and if your shrink factor is not going by 25%, you will say, well, that's not a shrink. So if you look at this mechanical scaling, every time you do a new generation, in fact, you change the mechanical principle of it. And that shows that, in fact, every product is a new product. Another trend is, and this is the way how MEMS system suppliers try to cope with the price decrease, it's in fact the same strategy that semiconductor companies are doing, increase functionality by integrating additional functionality, by integrating additional functions into one device at this context. And today, I mentioned traditionally we had one MEMS sensor, mechanical sensor, integrating with an ASIC. Today we integrate 2 to 3 MEMS sensors, which from point of view of a sensing principle are compatible. In this case, accelerometer, gyroscope, magnetometer. We integrate them with the ASIC, we integrate them with a microcontroller, and we integrate them with the software. That means from the component business, we had in 6 years of MEMS evolution, we already gone from a standard component business, we've gone to a total solution and a system business. And this is very fast. If you look back how long it took the automotive guys to go from component to total systems, it took them something like 25 years, and in some cases they are not even ready today. In this industry, it took us 6, not even 6 years. So that means challenge again, but that also means new answers to this challenge. And the good thing, whenever you have a breakthrough in integration, you will see how the market responds in terms, we open new markets, we enable new applications, that means we generate new turnover. One of these approaches where we tried standardization, and this is one approach to cope with this, call it volatility of emerging use cases, which are hard to predict. You can imagine we need 1.5 years to develop a new product, which is very fast, I would say, given the complexity. Our customers spin a new product every half a year. That means we need to predict 3 to 4 generations ahead what our customers are going to do with our product, because our implementation time are so long. So on one hand, you have a guessing factor. On the other hand, we are all engineers. We try to cope this with implementation flexibility. And one of the trends is we provide devices that can be configured. That means we provide devices that can be switched or programmed or tuned to different use cases, as for instance a BNO 055, which integrates a microcontroller and a sensor data fusion, which runs in smartphone, tablets, and laptops, but with additional software is fit for wearables at the first stage. And as a third variant of this product, we sell it to customers that program this device on their own, and they develop their own applications. So you might say, okay, this is not really new. I say, I agree. But what's changing, the changing point of this approach is not so much that we integrate more and more, we integrate hardware and software. This has been here since semiconductors exist. The changing point is that today we enable customers that initially were not able to do their own implementations of MEMS. We enable customers that are focused on design of headsets, of glasses, customers that don't know what's inside the sensor, and in fact they don't care and they shouldn't care, we enable them to manufacture a MEMS-enabled device. Again, as mentioned before, this enables new players, this enables creativity, new application, new markets. In fact, that's a growth engine. And I don't know how many of you are engineers, this in fact is the data sheet of this device. And when you imagine that inside you have an accelerometer, which comes a 50-page data sheet, a gyroscope, a 60-page data sheet, you have a magnetometer, a 60-page data sheet, you have a microcontroller user manual inside, and you have a software user manual. If you bring this pile to your engineers, which maybe might not be electronic engineers, they would just simply say, I don't do this. I don't do this, that's not a business. We bring this to them. And this is what user interface people understand, and this is what they can use. So that's the real innovation of it. The innovation is make it simple. Make it useful for people not deeply inside the sensors. And why I bring this example, because this will definitively be one of the key elements for Internet of Things applications. Because in Internet of Things applications, we will deal with customers that really don't care what's inside that small black chip or in that metal package. Oh, going the wrong direction. Okay. So what's next? Good question. I don't pretend to know what's next, but at least I think I know in which direction we should go to be prepared to whatever is next. And I think that's half of the way to go. When you look at these charts, you see lots of charts predicting a future. I think these ones are quite easy because they only look till 2015. So this is a quite short horizon. We will have devices connected, and you see, we're not really radical. When we do our prediction, we talk about 4 or 5 billion connected devices. But even serving this, we still need to do lots of homework. So we're not talking about trillions. I think the trillions will happen, but let's just argue when it will happen. 2015 is a predictable horizon if we manage this as an industry, and therefore I say thank you for inviting me, because as an industry now, MEMS will not be as independent as it was from the traditional semiconductors, because I see a huge merger in application and use cases between the traditional semiconductor people and the MEMS people. I'll talk about that one later. We can realize that. Another chart showing you how do we think the Internet of Things will be structured. It's more on a theoretical basis explaining why we think that there will be no Internet of Things without services. So therefore, when you see somebody from Bosch talking, you will always hear Internet of Things and services, because the hardware and the capability as such is useless if it does not provide additional value to the user. So we think there are 3 universes that will overlap and merge into a system and a service platform. Now, analysts say there will be, in average, 1 million users per platform, something like how many thousand global platforms with 100 services connected to one platform, whatever. This is more a marketing thing. The important thing is to understand the orders of magnitude of size differences. Internet of Things will probably be at least factor 10 to 100 bigger than the Internet of Users. That means simply every user in average drives more than 10 sensors till 2020. And something like 100 service providers will serve the global world of Internet of Things users. And that's an interesting figure. This is in fact done by analysts. I don't know who provided this as an internal study for Bosch. But this is an interesting figure because you can already realize where the battles will be. The battles will be here. Because this is where most of the business will be done, and this is probably the bottleneck of the business models. Nevertheless, there will be no business without sensors, and there will be no business without semiconductors, as GSA stands for. So I talk about this today. So when you ask what are connected devices, we tend to talk about domains. Domains is a bigger circle of use cases, and I think lots of articles. It's nothing new you see on this slide. In fact, everything that's surrounding our daily life will be connected. Question, what's the useful use case? Before I start discussing further, I'm just going to a short classification of what we define as Internet of Things sensors. And they're all coming from today, what's at the middle, to smartphone sensors, going to wearable devices, which, as a simple definition, need to be a factor 10 to 100 lower power than smartphone sensors today. And you know, today we're not there yet with all the sensors. So why today wearable devices are not as successful as we all thought 1 year ago? It's simply that today the hardware does not really deliver what it promises. It will, but it does not deliver today. The next thing is smart switches. This is rather low cost and low power budget, simple functionality. Smart switches, in fact, need to be a factor 10 cheaper than what we have today in smartphones. Again, this interesting factor 10. Smart switches. Why we don't have many smart switches today? Simply because they did not achieve the cost versus functionality ratio they need to achieve. On the other hand, we have the IoT nodes, which are the most complex devices. I will talk about that once. And we have the so-called IoT tags, which in fact is just a smart switch that's connected to the internet. For you to have it in the handout, to read the definitions, what's a wearable, what's a smart switch, a IoT tag, I won't go through that one. The main idea is to understand where are we today, what do we need to achieve in terms of power, cost, complexity, and infrastructure to enable the next level of MEMS. And with this chart, you can explain half of the future. And with this one, you can explain why horizontal and vertical cooperation within the industry is so important. If you assume a simple structure like that, this is a simple PowerPoint engineering slide, of course you need a MEMS, you need a battery, you need a microcontroller, and you need a RF interface. At this time, we all agree, but when we start to discuss which is the right RF interface for which application, then there are at least 2 to 3 opinions, probably even in this room. And when we start to talk about what is the power budget a MEMS should have, probably we would also have 2 to 3 opinions. And with these 10 to 20 opinions we have in the industry today, it simply does not happen. It does not mean this will not be solved. So I'm very optimistic on that. So I'm also not bringing a negative message by focusing on the challenge. It simply means that in terms of MEMS, we need to reduce cost power, again, factor 10. In terms of battery, we need to increase capacities factor 10. And in terms of transmitting average power, we need to reduce power factor 10. And then we have the Internet of Things nodes. We cannot do this as MEMS suppliers alone because these systems are highly interconnected. That means today we start working with power PMUs or PMIC chipset manufacturers. We work with wireless companies and we work with microcontroller companies. And the change is radical and fast. When I started in this business in 2006 to promote MEMS sensors, I just talked to the system integrators. It was a very simple model. Today, I need to talk to all these other guys. I need to talk to microcontroller, to software providers. I need to talk to RF providers. I need to talk to PMIC providers. So that shows there's a need for horizontal, but also for vertical cooperation. And that adds complexity. And that's the next challenge. How do we solve this cooperation complexity within the industry? I'm very positive we will. Some people say, of course, we will integrate the MEMS in the microcontroller and things are done. I don't think so. That's not the way it will work. But however, the traditional reflex in semiconductors is just integrate your partner or just eat your enemy or whatever, and you will solve it. It probably won't work in this context because the spread is too big. Nobody has such a big mouth. at the moment at least. So how are we going to solve it? I don't know. But I know that all of these people I'm talking to in the industry, they all have the right roadmaps. So I know that there will be a solution, at least to quite some perfection as of today, as 2020. So my prediction for the Internet of Things in huge volumes, probably 2020, and this simply by a guy sitting in the machine room fueling the technology machine. This is not by the perspective of a guy coming from the market. Another thing, and just as a closing slide, is what does MEMS do? MEMS makes our interaction, or sensors in general, it's not just MEMS, make our interactions with technology more natural, more human. Now that's a very simple way to control your apartment over a WeChat client. That's just one of the idea. But the vision, and this is the vision that drives the sensor guys, which fraction I represent, is that we interact with computers by motion, by speaking, by gestures, and we have simple interfaces to complex systems. And as long as we do not manage to make complexity simple for users, we will not see the success. Thank you.
Thank you very much, Dan, for the presentation. So before we move to the networking break, anyone has a question to Leo?
Hello, Leo, thank you very much for your insightful sharing. I can imagine that the MEMS and sensor is one of the key components in the future for our life. My question is about your page 19, about the IoT service. 19,
Yes.
Yeah, about the 3 pillars.
Yes.
And I think this research really great. My question is about the user experience. Bosch, how Bosch you deal with user experience? Do you set up research center, especially for user experience, to come out the better solution for the future life? Thank you.
Yes. A good question, and in fact, it also answers the question, why is Bosch into these sensors? Because if you know the structure of the Bosch business is hugely spread. It's automotive, it's industrial, it's power tools, it's white goods, it's automation, it's factory automation. So it's a hugely spread business. And the question is, you might ask, what's the common denominator of this business? And one of the common denominators is user interface. The second common denominator is, imagine you will link all these businesses. And that explains why first, yes, we have our own user experience group. We have a division that focuses with user interfaces. They also work with our devices and they provide feedback to us. And secondly, as you know, the announcement on the last CES, even the fact that Bosch is at the CES in Las Vegas constantly now shows a change in the mindset. The last announcement was that all these devices, of course that makes sense, that Bosch will have an internet or a hub connection. That means we at Bosch, we decided that we do the Internet of Things for the devices we do. Unfortunately, we do lots of devices in lots of different industries.
Okay, Nikki.
Yeah, Leo, I want to express my appreciation to your excellent talk. You show us that the product cycle almost like Moore's law every 1 or 2 years. And you also expect that the demand will going up. So what about the investment cycle and also the, profit level? Is that growth, sufficient ways of doing business?
Yes.
Will the customer pay you to the degree that you keep investment in?
It's a good question. I know where this question will lead to. But I'll wait till your second question then.
I'm not trying to negotiate.
Okay, no, I know. No. It will lead to another thing. You will probably ask me when we see MEMS in the foundry. That will be the next one. And I can answer both, of course. So, and I will. So, yes, we see, we need to detach two things. One, the investment base, which we invest on technology, and the product spin. And the art, probably, it's same in semiconductors, to detach technology platform from product platforms. Our product platforms spin very fast, and even this very fast spinning today is not fast enough, so we introduce flexibility. Our technology platform, which holds the investment, which holds the invested capital, stays mainly the same. The challenge on these product platforms, and that brings you to what I anticipate is the next question, the utilization of this investment, of this capacity. And at the moment, we've seen huge growth in the industry. In the last 3 to 4 years, we were under capacity. Mainly, we could not deliver as much as our customers wanted. But as I anticipate a slowdown, we will have to think about how do we utilize this invested base in capacity. And I think, yes, this will be an issue in the next years, which we can again maybe sort out by technological solutions. We run more products on same platforms, but we probably need to merge businesses. And when you look at why Bosch is doing automotive and consumer, you already see we have a perfect blend in between. When automotive was down in 2009, consumer was booming like hell. So we had 80% of the fab for us. And this was the first time when it really paid off to be diversified in terms of industries. So I answered the first question.
Thank you very much, Leo, for a great presentation. So, Jody, would you like to present the gift to our speaker? Thank you so much. Thank you.